most of my talk is around how we have used public data, what is available in Estonia, and how we have used it for Estonian government or public institutions. So it's I picked projects where we use their data for their own code, and I've just highlighted some of the workflows we have been working with. So there's certain data providers. Some of them are better, some of them are not that good, but overall trend in Estonia, at least everything is public. It's quite easy to access. So just to put a little bit of a context for our work, we try to answer usually some questions which our clients have had. And from their perspective, there's some sort of a structure. There's questions related to how people are moving, what's the relationship, where they go and how do they go. Something similar what Andres was talking previously. Then there's some sort of analytics which are physical, like regarding the built environment, also trees and surface and networks. And then there's a behavior part, how actually people are behaving in that environment. So the first set is a people-centric questions. There's always question where people actually live, and there's a multiple data sources. And what we have found most useful is an address data set, dwelling units, which seems to be least fluctuating. Like if there's a building with a certain number of rooms, then we have a good sense how many residents there are. Population registry and census, there has been a lot more of these problems. It is much more problematic in a way where people actually go. In context of Estonia, we don't have a very good data set where people actually work or how many visitors there are in a certain time frame. So and it's a much harder data set as well, because if we think about where you live, you most likely live in one place, but work is much more flexible. One person can work in multiple locations, and there is a job sometimes requires also multiple destinations. So that is always have been hard for us to predict where people actually go. And then there is a question regarding how people get around. There is a network, a physical infrastructure where people actually could walk, and there is multiple data sets, but they rarely cover well pedestrian networks, and they don't go into the inner blocks and the stairs and like all these things are not actually part of the data set. It is usually much better for the cars, but there hasn't been a good movement for, or like a good data set in context of Estonia for pedestrians, which is nationwide. The Tallinn and Tallinn and Estonia have two different data sets held by Maa-amet and Tallinn, and they don't match on a border. So even if the Tallinn is better, it kind of ends in very sharply. So very often we have went back to the OpenStreetMap, which is covers all the walkable parts. But it's kind of critical for example, assessing whether the bus stop is actually accessible or not. And the one which is not really physical, but is a public transportation data set, and that is in context of Estonia is good that it's a single location where everything is held. So you can easily route people with the trains, local buses, regional buses, and all sorts of different things. So we can use public transportation as one way of calculating how reachable certain areas are. In case of built environment, there is a set of buildings. Now it's getting better. Previously, we have had 2D footprints, and then from the LiDAR, we had to get this thing physical. And there's all sort of meta information. But usually, some of the classifications are, for example, putting together industry and public buildings. So in the theater and factory are on the same classification. Or some of these things could come up, and it's hard to say again. Say actually I made a mistake. There is a shed in a backyard. The factory are the same classification, and the public building, the residents are the same. So, and then there's a land cover and elevation, where the one key thing is a canopy cover. Usually meant for the estimating how much forest there are, but in a context of a city, I show later on a small project where we estimated how much of your typical route might be covered with a canopy. And then there's also the travel, a behavior part as one of the data sets. Usually it consists of public transportation, where we have a tap-in data, plus every single bus, at least in the Tallinn context, has a real-time sensor, like real-time GPS updated all the time. So we have been using it for some of the project, plus the bike share programs. A traffic counting rideshare usually is not very publicly available, so it's hard to use them. Then there's a reference project like surveys, but there are only limited way of them, but to build up more reliable environment, reliable decision tree. And then there is some of the demand data set, for example, mobile positioning and workplace registries, but they are a little bit in a gray area here because they are not per se publicly available. So I don't use this much today. So what we usually try to do is we take the data, we try to come up with some sort of abstraction or simplify for a question and present it with a narrative or how to make a decision. And one of the side product is we try to avoid single targets, but aim for multiple targets. Not all people have to have a certain access to jobs, but certain areas should have a different ones. So that's the a high level what we are doing. And there are some projects what I'm going through, and I'm just picking a small aspect from each of them. So the first one is a Tallinn 21 plus, where we were working on indicators, and I'm talking about two of them. One is access to public transportation, and there we propose that there should be one aim, a percentage of people who can reach to the jobs under 30 minutes. It's a one indicator, and then we can there was 10 most potential destinations where people might want to go, and then we can evaluate, see how it changes from the year to year, and there could be changing two things. First of all, the public transportation can be faster, and the second one is they can allocate people or closer to the public transportation. So what we used is that we took 7 to 8 5-minute interval and calculated average how much time it actually takes to get there. So it's not the best case, it's not the worst case, but it's kind of an average of them all. And that's on a side we see different visual representations how much it takes to get certain locations. And this is now up and running in Tallinn Strategy website. Another one which is much more kind of, there's only one number, but the calculation was much harder. They wanted to have a indicator for percentage of your typical route, how much of it is covered with some sort of greenery. So we took the LiDAR data set and brought it down to the 5-meter grid, calculated average height of the trees, assign it to the 1 point, and then use this 5 by 5 meter grid for sampling how much it is covered on your walks. And we only used immediate surrounding, 600 meter, which are like bus stops, schools, whatever was in the range to estimate that. It's definitely an error because like we don't know exactly where people are going, but that's kind of an estimate. And what we meant by the then we sampled every like 20 meters how many of whether this particular location is under the trees or at least the trees are around you. So if there is in the 15-minute range, there is a 5-meter high tree, then it's under tree cover, or like if we can't find the tree, then whether there's 180 degrees around you trees, then it's also considered somehow walking in a greenery. So maybe the ground cover is not the best word, but that's you're surrounded by the greener areas. Another project was we were working on a public transportation project, and there we worked out whether there is possible to fine-tune the schedule for a different public transportation. And here is example of bus 33. One of the tools we worked out is that we see how reliable it is and which of the stations we can shift around. On the left side, there's how precise it is, like the one number. On the right side, we see all different stations over a period of month, how precisely they arrive there. And if we look every single station time-wise, then we can find a certain, we can see difference, and whether there is a difference in day or daytime, or there is a difference in the geometry. So on the left side, the station behaves quite predictably. On the right side, there's it's pretty unpredictable. It can be late a minute or so occasionally, and but if we find the station which is predictably, but they are always early, then they can shift a schedule based on that type of plot. So it has a visually they can distinguish what's the which way to change schedule. Another type of thing was we collected real-time data on all public transportation in Tallinn, and then reduce it to the line segments. And on the right side, there's a raw data. On the left side, there's a raw data. On the right side, there is a put it to the 100-meter segments, and the numbers show the average speed over months on that particular tramway. So, and the red numbers actually show how many seconds they stay on the station average. So that again throws out like whether the turn is a problem or there is some other things which is a problem. So actually, tram in sometimes gets the it's quite fast, but on a turns and some locations it could get slower. The hardest part is actually to define what is the stop and what is, so we had to redraw pretty much entire city and define the stops and where they, which are the stop points and which are the movements. So next project is the Tartu bicycle strategy, when one of the tasks was to see where people actually go and look in a very, very broad picture. And there we took a couple of months of bike tracks and traces and put it on a map and intersect it with a grid. And on the right side, we can see that each cell shows a percentage of trips passing through this particular cell. So it was at that point we didn't match it to the particular segment because like even like on two different sides and all sorts of small technical problems. We thought the grid gives like a very broad picture on a behavior. So in Tartu there is a sector where quarter of trips are passing through, and certain larger directions are drawn in a very, let's say, strategic level. We can say like if you want to do something, then start with these particular routes and sections, and it's not going to the detail what exactly to do. Okay. The second project was with Tartu. They wanted to define a center, and there we calculated a lot of different things. Like to be in a center, a walkable center, you have to have a certain amenities around you. So there's a school need to be at least in our case it's 1,200 meters, and then there's a kindergarten. And they're all calculated from the parcel and whatever the best part of the, if parcel has multiple edges, then we divide it to the 25-meter blocks where they can all reach. And the best one is picked out. Also, that's a little side on what we didn't use is the cycling, like 2,000 meters, how many jobs can be reached, and then there's a certain gravity towards the railroad. So it was kind of interesting that since that Tartu has jobs on one side of the city, it was a little bit surprised that that part was a cycling-friendly areas there. And then there's also what we use previously, public transportation access, again sampling over the morning peak hour, 5-minute interval, and see how many different jobs we can reach, and then there's we can put them all together and say like where would be a center where you can do most of the things by on foot, and there's also areas like which is missing, like on in case of red they could add like a food store, or like in the bottom part if they add more services, or the green if there is a more like food and beverage amenities, then they can extend the centralized areas with this direction, but it kind of gives a guidance like what is missing probably on that area. And the last project is very physical. The Heritage Board asked us to, on Kuressaare and Pärnu, whether how do developments affect visibility to one particular church in the case of Pärnu, and Kuressaare Castle in case of Kuressaare. And for that we use, that was before there was available the LOD2 models. We use footprints from the and lidar roofscapes, and if there is a visible connection from that's 1 by 1 meter grid, and if there is a connection to the church tower, we draw it with we left the point, and if it wasn't, then we just killed the point, and then it draws out the visible areas for the tower. And if there was planned developments, we could show pretty much accurately where this particular church is not visible anymore. So that could be used in other cases as well. For example, finding the good location for this with a sea view of Tallinn or something like that. So that's from my side. Thank you. I hope I was on time.
Thank you, Raul, for the great presentation, and the examples are really great of how to use public data to visualize what is happening regarding urban developments. You will be back with us in the panel, and we hope to have a lot more questions for you there. Right now, I would just like to ask, how important is this data visualization to decision makers? And have you also seen tangible results based on this visualization of data?
Mm-hmm. I guess there's a couple of things. One is visualization is important aspect of making decision, but it needs to be multiple levels. Like occasionally you would like to have a target of something, and then data visualization just shows you how it is located on the ground. It's easier for to spot the mistakes and see more fine grain. So I see the projects always like multiple levels in case of urban context, and like you have a clear idea what one map is showing. So it needs to tell the story, or like describe in a easy way. And the data availability is important. So I have a sense like the government should take care of the data collection and data quality. And I think the small projects, but around the world, are like could be work out proper methods, and so that I don't think it, because like it moved. There's so many things you can ask from data. You don't have to work with the tools, and then it's kind of energy goes in the wrong place. So that's why I always emphasize that government prepare the good data, and we can take other tasks.
Well, we certainly try to do that at the Ministry of Economic Affairs and Communications as well. And we can talk a little bit about that maybe later on in the panel. Thank you again, Raul. So see you in a little while.